Let's start exact differential equation. That is, let's start exact differential equation. Exact differential equation. Uh, for example, let's take this example, that is x dy plus y dx is equal to 0. By separating the variable, by separating the variable, we get dy upon y minus dx upon x. Then integrating both sides, you get log y minus log x plus log c. So this is log xy is equal to log c. So xy is equal to c you get. So xy is equal to c is exact solution of this one. Or we can say that कि x dy plus y dx is equal to d of xy. अगर मुझे इसको इंटेग्रेट करना है तो I will get directly answer of this one. Okay, so then integration of this one is equal to this one, because इन इक्वेशंस को हम डायरेक्टली लिख सकते हैं फंक्शन ऑफ समथिंग. यानी कि जो अगर एक इक्वेशन और लेके चलें तो वाई डी एक्स माइनस एक्स डी वाई इज इक्वल टू 0. So this is by separating the variable. Log c, so this is log of xy over log c. So this implies x over y is equal to c. So this means that we can write this question as, हम इसको ऐसे लिख सकते हैं d of x over y. यानी कि ये इक्वेशन भी इस इक्वेशन को हम ऑब्टेन कर सकते हैं फ्रॉम डायरेक्टली सोल्यूशन. तो जो भी इक्वेशन को हम डायरेक्टली सोल्यूशन से ऑब्टेन कर सकते हैं, दैट इज कॉल्ड एज एग्जैक्ट डिफरेंशियल इक्वेशन. Let us see that what is the exact differential equation. We can say that so mdx plus ndy is equal to 0 is exact differential equation. Exact differential equation if there exists a function u of xy such that mdx plus ndy is equal to du, then we say that the equation is exact, and this is the most important result. And if I say that u is a function of x and y, then what is the total derivative of u? That du will be equal to curly u by curly x, partial derivative u with respect to x into dx, then derivative u with respect to y and dy. And second result that is very important is that if un is a continuous function, then curly square u by curly y and curly u curly y x are equal. So you can change the order of the derivative. Now let's draw necessary and sufficient condition for mdx and dy to be exact. The necessary and the sufficient condition. Necessary and sufficient condition for mdx plus ndy equal to 0 to be exact. That condition is necessary and the sufficient condition for mdx plus ndy 0 to be is exact is that m and n they are function of x and y, are functions of x and y with the condition that mn, its partial derivative, are continuous function of x and y. Now let us derive its necessary and sufficient condition for the functions to be exact. Proof. Necessary condition. Necessary condition is mdx plus ndy is equal to 0 is exact. That is, by definition, it should be, there should exist some function u where u is a function of x and y. U is a function of x and y. X and y. Then let's and अगर एम डी एक्स प्लस एन डी वाई अगर एग्जैक्ट है एम डी एक्स प्लस एन डी वाई is equal to du and u is a function of x and y. So by definition we know that du can be written as curly u by curly x dx curly u by curly y dy. तो देन इनको कंपेयर कर सकते हैं हम यहाँ पे एम डी एक्स प्लस एन डी वाई इज इक्वल टू curly u by curly x dx curly u by curly y dy, comparing the coefficients of dx, comparing. So what we get, m will be equal to curly u by curly x and n will be equal to curly u by curly y. Now I want to eliminate this u. So अगर इसको मैं y से partial differentiate कर दूँ, इसको x से कर दूँ तो u eliminate हो जाएगा. Then we will find the condition. The partial differentiate with respect to x. Partially differentiate with respect to y. So I will get curly m by curly y, curly u by curly yx, and I will differentiate with respect to x, curly n by curly x. So this will be equal to curly u by curly x, curly y. Now because we have done, because curly square u by curly y curly x, that is equal to curly square u by curly x curly y. Therefore, if right hand side is equal, then left hand side will be equal. So curly m by curly y is equal to curly n by curly x. So this condition is necessary. If mdx plus ndy is exact, then this condition must hold.